Our universe began around 13.8 billion years ago with the Big Bang, erupting from a singular point into the expanding cosmos we observe today. It's been creating galaxies, stars, planets, and life for billions of years. Yet for all its magnificence, scientists are certain of one truth: it cannot last forever. One day, somehow, the universe will end. But how? Modern cosmology offers several intriguing possibilities, and in this video, we'll dive into 3 of the most fascinating and well-studied theories. Each one paints a dramatically different picture of the cosmic finale. Some envision a cold, silent darkness. Others imagine a violent, fiery collapse. Let's start with one of the most accepted scenarios, the heat death. The heat death, also called the Big Freeze, is one of the most widely accepted theories about the ultimate fate of the universe. To understand it, we need to consider a fundamental law of physics: entropy. Visual. Entropy is the measure of disorder in a system. And the second law of thermodynamics tells us entropy in the universe can only increase over time. Right now, stars are burning fuel, creating energy and structure in galaxies. But eventually, that fuel will run out. Stars will burn out, leaving behind cold remnants like white dwarfs, neutron stars, and black holes. No new stars will form, because the gas needed for starbirth will be used up or locked away in black holes. Galaxies will grow dark. The universe will expand further, stretching light into oblivion. In trillions of years, even black holes may evaporate via Hawking radiation. Ultimately, only a thin, cold soup of photons and subatomic particles will remain. The cosmos would become uniformly dark, cold, and nearly empty. A silent expanse with temperatures approaching absolute zero. Time itself would march on, but there'd be no significant events left to witness. This is the heat death, a universe that ends not with a bang but a whimper. And while it sounds bleak, it's the scenario most cosmologists currently lean toward. The second theory proposes almost the opposite fate: a cosmic contraction known as the Big Crunch. Instead of expanding forever, the universe's growth could one day stop. Gravity might gain the upper hand over the outward push of cosmic expansion. If the total mass energy density of the universe is above a certain critical value, the mutual gravitational attraction of all matter could halt expansion and reverse it. Clusters would merge, and the entire cosmos would contract. Stars, planets, gas clouds, all collapsing toward a single point. Eventually, the universe could become a scorching inferno, a dense cosmic fireball resembling the conditions of the Big Bang in reverse. Some physicists speculate that time might even run backward as the universe collapses. Ultimately, all matter and energy could squeeze into a singularity, a point of infinite density. And in some versions of the theory, this collapse could trigger another Big Bang, starting a new universe in an endless cycle of death and rebirth. This concept is known as a cyclic universe. But so far, measurements suggest our universe's expansion is accelerating, not slowing down, which makes the Big Crunch less likely today. Still, it remains a tantalizing possibility, reminding us that cosmic forces could one day reverse the flow of existence. It all starts with dark energy, the mysterious force driving the accelerated expansion of the cosmos. Astronomers discovered in 1998 that the universe isn't just expanding, it's expanding faster and faster over time. Dark energy is the name given to whatever causes this acceleration. But we still don't know exactly what dark energy is, or how strong it might become in the distant future. If dark energy's influence keeps increasing, it could eventually overpower every fundamental force in nature. In a Big Rip scenario, galaxies would first drift apart faster than the speed of light, becoming isolated islands in a vast cosmic sea. Then, as dark energy strengthens, gravity would lose its grip. Stars within galaxies would break apart from their stellar neighborhoods. Solar systems would unravel, planets flung away from their stars. And eventually, even atoms themselves could be torn apart as the repulsive force of dark energy overwhelms the binding forces at the subatomic level. The timeline for this catastrophic scenario varies. Some calculations suggest the Big Rip could happen in 22 billion years, if dark energy becomes sufficiently powerful. Others believe it might never happen at all, depending on dark energy's true nature. But if it does, the universe would end in an explosive shattering, with all matter reduced to a soup of fundamental particles, scattered across an ever-accelerating void. It's a vision of cosmic destruction, both majestic and terrifying. So, which theory is right? The truth is, we simply don't know yet. Cosmologists are gathering new data every day using advanced telescopes and particle accelerators. They measure cosmic microwave background radiation, map out the distribution of galaxies, and study the movement of distant supernovae. These clues help refine our understanding of the universe's fate. At the moment, evidence points toward continued expansion, making the heat death the leading candidate. But the universe has a way of surprising us. A new discovery about dark energy, gravity, or the nature of space-time itself could change everything we believe about the end. That's what makes cosmology so thrilling. It's the science of the biggest questions. Questions about how it all began, and how it might all end. No matter which theory turns out to be true, one thing is certain: the universe is a place of unimaginable scale, mystery, and wonder. From the dazzling birth of stars to the quiet depths of interstellar space, we live in a cosmic story that's still unfolding. And whether it ends in a freeze, a collapse, or a cosmic rip, it's a story worth exploring for as long as we can. Because in seeking the end of the universe, we discover more about where we came from and who we are. So keep looking up. The final chapter hasn't been written yet. Thanks for joining us on this journey across time and space. Don't forget to like, subscribe, and share if you love diving deep into the mysteries of the cosmos. Until next time, stay curious.